So far we've looked at series that we could classify: geometric series, p-series, telescoping series, those sorts of things. And then from those we've been able to determine if the series converges or diverges. Today we're going to look at some series that are not quite so easily classified. So we might look at one that is 1 over x to the third plus 5, or 1 over 3 minus the square root of n, things like that. Not so obvious what these are. So we are going to need a different tool for us to be able to determine if it converges or diverges. And that's where the direct comparison test comes in. We're going to have a series and that we want to determine if it converges or diverges, and then we're going to choose a series that we can compare it to, and we need to pick a series that we can determine the convergence or divergence of. So that's sort of where we're headed with this. Alright, so it says let 0 be less than a sub n, less than or equal to b sub n for all n. So we're just going to let one of our series be a sub n and one of our series be b sub n. Okay, so maybe this first one is the one that I was given and I want to determine its convergence, so I would let it be a sub n. And then I'm going to pick a series with which to compare this series to, and I'm going to let that be my b sub n. Okay, and so that's the one I've got to pick. A lot of times you're going to end up picking one that's very similar. Maybe it's got the one we're trying to determine has got these extra plus, constant, minus a constant, something of a smaller power. And you can sometimes just sort of strip that away and then choose your comparison series without those extra little pieces. So for like this one, I would end up choosing 1 over x cubed and starting from there. Sometimes the most obvious one doesn't work. A lot of times it does, and we'll see that when we get to the examples. Alright, so here's the key though. You're going to compare these two series and see which one's bigger than the other one. Now I've said if a sub n is less than or equal to b sub n. That doesn't mean that you always have to choose a series that's bigger than the one you're trying to compare. Maybe I've decided to let this one be b sub n and this one be a sub n. It doesn't matter which one you call which. You're just going to have one series that's smaller than the other series. Okay, so once we have that two series, one is smaller than the other series, then if the bigger series converges, then the smaller series converges, and that should make sense. The bigger series with the bigger terms sums to a number, then the smaller series will also end up summing to a number. Not necessarily the same number, of course, but it will converge. Okay, and likewise, if the smaller series diverges, then the bigger series will also diverge. So that's kind of a common sense thing. Two notes, the comparison will hold true whatever integer n starts. I have it in these notes starting at n equals 1. It could be at n equals 5, n equals 100. It doesn't matter. It doesn't have to start at 1. You do need to have positive series, remember that, but n doesn't have to start down at right at 1. And then also note too, you want to be careful with your comparisons. What we're saying is if the bigger series converges, the smaller one converges. If the smaller series converges, it doesn't tell us anything about the bigger series. So be careful with the comparisons and make sure you're drawing the right conclusions that you're able to. There are going to be times when your comparisons will not give you a conclusion and you'll have to try something different. So just be aware of that. All right, let's go ahead and actually work some out and see. This is really an easy test to use. You just got to be sure you pick a good series to compare it to. All right, determine the convergence or divergence of the series from 1 to infinity of 1 over 2 plus 3 to the n. So this is a series. It doesn't quite fit into the mold of the ones that we've looked at before, although it looks very similar to one. Okay, so what we've got, I'm going to let a sub n be 1 over 2 plus 3 to the n. So I need to pick a b sub n that's similar to it, and I'm going to strip off the 2 that's in the denominator, and I'm going to compare it to 3 to the n. And I like that because that's a series that I'm already familiar with. It's the geometric series that has r as 1/3, and so I can easily determine the convergence or the divergence of it. So I'm going to start with that. Okay, so the first thing I want to show is I do want to show the inequality between these two series. And what I know is that 1 over 2 plus 3 to the n is going to be smaller than 1 over 3 to the n. How do I know that? I know that because 2 plus 3 to the n is bigger than 3 to the n, and since it's in the denominator of a fraction, then that fraction will be smaller. So I've got that. You do want to show that comparison. That is part of this test. Okay, so 1 over 2 plus 3 to the n is less than 1 over 3 to the n. And then I want to show that 1 over 3 to the n is a convergent geometric series okay, and I know it's a convergent geometric series because r is 1/3, which is less than 1, and the absolute value of it, you could say, right? Okay, you could also say that if you wanted to word it a little differently, you could say 1 over 3 to the n converges, that's an n, converges by GST. Okay, so don't think you have to use my exact wording on any of these things. Just know that that is a possibility as well. Okay, but you want to show the series that you picked. You want to show the inequality between the series, and then you want to show that the one you picked converges or diverges. And the test that you know the reason why you know it does that. Okay, so back to this. 1 over 3 to the n is a convergent geometric series. 1 over 3 to the n is bigger than our given series. Therefore, I'm going to use my 3 dots. Therefore, the series as n goes from 1 to infinity of 1 over 2 plus 3 to the n converges by the direct comparison test. And it is okay for you to abbreviate this. I really need to be able to type this. So you can abbreviate it DCT. Okay? So I have listed here those things I was saying, the things you want to show in your justification with your conclusion drawn. Okay? If 1 over 3 to the n had been smaller than 1 over 2 plus 3 to the n, we would not have been able to draw any conclusion because 1 over 3 to the n converges. So we were able to pick a good series that the comparison worked out, and we were able to determine that this series converged. Okay, let's try another one. Okay, example number 2. Determine the convergence or divergence of the series from 1 to infinity of 1 over 2 plus the square root of n. Okay, so this is another one that is almost one that we can determine, but not quite, thanks to that extra 2 that's in the denominator. So I'm going to go ahead and pick a series, and I'm going to pick the series 1 over the square root of n, or if you want to rewrite that as 1 over n to the 1/2. Okay, and I'm going to pick that because it's very close, and all I did was get rid of the 2 in there. All right, so we've got this one, and we need to determine if it converges or diverges. But first we need to show the inequality. And the inequality is going to show that 1 over 2 plus the square root of n is smaller than 1 over the square root of n. And again, that's because 2 plus square root of the n is bigger than the square root of n, so be careful with those. But we've got our inequality set up. So now we're going to talk about whether or not our chosen series diverges or converges. So this is 1 over n to the 1/2, which is a p-series, and it's a p-series where p equals 1/2, which is less than 1, and therefore it diverges. But that's a problem. And it's a problem because it's the bigger series, and if it diverges, it tells me nothing about the smaller series. So I can't use that as my comparison. All right, so I need to choose a different series to compare to. You don't necessarily quit. You just sort of think to yourself, well, maybe I need to try something else. One thing I will say is that when I stop and think about it, I say, well, 1 over the square root of n diverges. So I'm thinking that this series is going to diverge because it's so close to it. I just have to be able to choose a series that I can use to prove that it diverges. So I need a series whose values are actually smaller than this one, which means that the exponent of my n should be bigger than 1/2. So I'm going to go to a series that you're going to get very familiar with as we continue to go through this unit, and I'm going to go to the harmonic series. It's very close to 1 over the square root of n. It just has an exponent that's a little bit bigger. I know that 1 over n diverges, and since I think 1 over 2 plus square root of n diverges, then this might be one I can compare it to. So we're going to first do our inequality and see how this works. So is 1 over n bigger or smaller than 1 over 2 plus the square root of n? And it may not be super obvious. You might want to try plugging some numbers in. And I wouldn't pick numbers right around 1 and 2, those low numbers, because remember what I said at the beginning is the inequality doesn't have to hold true for those small values of n. So I would go to bigger ones. And so, maybe start at n equals 100. When n equals 100, 1 over n is 1 over 100. 1 over 2 plus the square root of n is going to be 1 over 2 plus the square root of 100, which ends up being just 1 over 12. And so 1 over 12 is a bigger number than 1 over 100. So we're looking at 1 over n being less than 1 over 2 plus the square root of n. You probably ought to try a couple more and see if that holds true, and you're going to see that it does in fact hold true. 1 over n is less than 1 over 2 plus, I wrote the square root of 2. Sorry, that should be the square root of n. Okay, and so there's our inequality. And that works for us, because since the smaller series diverges, and we can just say it's the divergent harmonic series, and since the smaller one diverges, then the big one will diverge. So, therefore, the series, n equals 1 to infinity, of 1 over 2 plus the square root of n diverges by the direct comparison test. Okay, so let's look at another example. All right, example 3. Determine the convergence or divergence of 1 over 3n squared minus 4n plus 5. So what would be a good series to choose for our comparison? And I would just go for 1 over n squared. Don't worry about that coefficient in front of the n, because it is not really when you start talking about big values of n, it's going to infinity. So when n's 100 million and you're taking 100 million squared, that 3 isn't going to make much difference. So I'm going to just compare it to 1 over n squared. So the first thing I'm going to do is determine which one's bigger, which one's smaller, and 3n squared minus 4n plus 5 is going to be less than 1 over n squared, because that, for really large values of n, that denominator is going to be larger. So 1 over 3n squared minus 4n plus 5 is less than 1 over n squared. So now 1 over n squared, we need to determine its convergence or divergence. This is a p-series, and it's a p-series with p greater than 1. That means that it converges. And since it's the bigger function, or the bigger series, then the smaller series, I always want to forget to write this. Okay, 1 over 3n squared minus 4n plus 5 converges by the direct comparison test. Excuse me. That is just a mess. Let's fix that. 3n squared minus 4n plus 5. There we go. Okay, so there we have our conclusion. We've shown our inequality, and we've shown our understanding of what the divergence or convergence is of the function that we are comparing it to. All right, one more example, and then we'll be done. So we want to determine the convergence or divergence of n squared over 4n to the 5th plus n cubed as n goes from 1 to infinity. Okay, this looks a little different because all the ones we've done so far have just had a 1 up there in the numerator, and this one now has an n squared. So this might give you a moment's pause as you try to figure out what to compare it to. But if you think about it, this is very similar to n squared over n to the 5th. And that is going to behave like 1 over n cubed. So we're going to use 1 over n cubed as our comparison on this series. So the first thing we need to do is to determine what our inequality is, which one's bigger and which one's smaller, and this could be a little bit difficult to decide. Again, plug in some values and see what's happening as n gets really big. What I do know is that this extra n cubed out here is going to skew this as well as the 4, so that this denominator is going to be bigger than just n cubed. The n squared is, you want to think about it and make it have a lot of weight, but it's going to simplify and behave down as if it's 1 over n cubed. So, just plug in numbers if you're not comfortable with doing this without it. So, but what we're going to see is that n squared over 4n to the 5th plus, n cubed, not 3 to the n cubed, is less than 1 over n cubed, because the denominator of the first one is much larger. Okay, and then what we see is that 1 over n cubed is a convergent p-series because p is greater than 1. All right, and since it is the larger series and it is converging, then therefore the series is n equals 1 to infinity of n squared over 4n to the 5th plus n cubed converges by the direct comparison test. And one thing I haven't really done that I've done in past videos is it is still okay for you to come in and just assign the series a letter, you know, S sub n or whatever, and then instead of writing it out and taking that time, you could just write S sub n converges. That's fine as well. You also can assign this and let this be B sub n, and you could, you know, let this be A sub n, write it out, let it be A sub n, and so then when you're doing your comparisons, you can do this, and you could write B sub n here. So, you know, once you've identified and defined those variables, then you can use them instead of rewriting over and over again the series and the fractions to save you a little bit of time on the AP test. Also keep you from making all those mistakes, you know, that I tend to make when I'm copying things incorrectly and that sort of stuff. So, all right, that's it. Hopefully you've got it. Let me know what questions you have and work on those problems.